Welcome back to the PreVetted Podcast, where we spotlight extraordinary people and remarkable talent reshaping our world. Today, I am joined by Nirmal Jingar. He's Senior Technology Leader for AI, Platforms and Modernizations. He leads AI and supply chain engineering across a 10 billion global e-commerce operation and has driven over 300 million in cumulative enterprise impact through AI-driven optimization and platform modernization. Nirmal, welcome to the show.
Thank you. Thanks for having me.
It is truly an honor to have you here today. So for people meeting you for the first time, can you describe a little bit more of what you do?
Yeah, sure. So usually I say I work at the intersection of technology, operation, and business scale. In more of a funny word, I help supply chain, but I move the furniture, right? Owning the supply chain, multiple systems. I'm in the tech industry, worked with like smaller companies, medium companies, large scale companies. Over the 10-year, my focus has been supply chain, logistic, e-commerce, all of that. Yeah. So in a simple version, I build and scale technology system that help complex business operations.
Right. And logistics is one of these multivariable complex problems, right? Where it's hard to intuitively try to solve it, right?
Yes, there are so many variables into it. Like it's not just like one logistic system or one software or platform. There are human involved into it. There are decisions involved into it. That logistic system is connected to like multiple other systems. So many things happening.
Right. And the level of complexity and, tracking the changes, when you do a change on this complex system, there's an inertia to it that it's hard to track from the change to the outcome, if it's a positive or negative outcome, right? It takes a lot of time to actually be able to figure that out, right?
Yeah, it's all depend on the scale. Like if a smaller scale, it's easier to find out those things. At a larger scale, at the enterprise level, it's really hard. So that's why I recommend people to like build for the enterprise from day one, right? Don't just start working on the prototype or start working for the smaller scale, but make sure your design and architecture and building for enterprise is the main focus from day one.
Right. And what other particular challenges does scaling a supply chain system has at a global scope?
So really good question. I think the main things come from the order of volume, right? How many customers are buying and how do you align your forecasting with the actual order volume? Like that's a very, very difficult problem for any supply chain to scale it, right? So take an example of Black Friday sale. If you have a Black Friday sale, hypothetically, let's say company X, they thought they are going to receive 10,000 order per minute. They did not receive 10,000 order per minute, but actually they started receiving 50,000 order per minute. So what do you do in that situation? How do you change the whole planning of the supply chain? Because this is going to impact everything in the supply chain, right? You have to make sure you have the right inventory. You have to make sure you have the right product next to the customer, as close as to the customer, so you can ship faster. You have to make sure you have people in your warehouses so they can move the inventory, right? And then also based on if you are working with FedEx, USPS, or any third-party carrier, you have to make sure you give them the advance heads up about the number of orders or the volume you will be receiving.
Right. You bring an interesting concept that is you are somehow predicting the future, trying to predict the future so you can be prepared and reduce the time to response as much as possible, right? That's very interesting because I'm more used to react to a user input or react to a build system that reacts rather than try to predict and save time.
And predicting the future is the hardest thing, right? You never know what will, you decided the forecast is X number of orders, but the reality could be completely different. So that's why I recommend, like, it's all going back to the basics of system design, right? How you are designing your system. Are you making sure your system is scalable? Have you spent enough time in building the right architecture? Can your system handle like 10x or 100x types of requests that you have as of today?
Right. Right. And how do you see the use of AI in this complex system? What are the benefits of how can you leverage AI to solve this problem, basically?
Yeah. There are a couple of things where AI is very, very useful here. I will start with the execution first. So, building and writing code has become like very easy and very fast. So, I have seen the speed of the execution has drastically changed now. So now the human are focusing more on like brainstorming. They are involved into the judgment, designing the system, asking tough questions to the AI tools when they are interacting and building something, and reviewing the output of the AI, right? Because I still want to make sure my teams and my engineers use their own judgment and don't leave everything onto the AI and just blindly accept the AI output, right? So human is still very, very critical because human has the subject matter expertise, human has the domain knowledge, and human can do the trade-off and can understand very clearly what is the customer impact, what is the business impact. So using the AI as a thought partner, not as a replacement of the human, right? So this is the execution part of it. The other part of it, like triaging and finding out the problems, right? So if you think about the massive enterprise level scale systems and software, there are so many moving pieces, there are so many teams, so many systems. And sometimes for a human, it really takes time to dig into detail, find out the root cause and do the root cause analysis and everything, right? So AI is really good at that. So all the burden that human had, now we can replace with AI, right? So AI does all of that for you, whatever tools you are using, and you get that information and root cause analysis much faster. And then the engineer or human make the decision like what they want to do based on the recommendation which came back from the AI tool.
Right. I've been thinking about this idea of accountability. Who is accountable for the agent actions, right? And my thesis is, or my position is that the human that is supervising those agents should be responsible. That is aligned to, rather than human replacement, human augmentation using AI, right?
Yep.
And at one point I thought that agents were going to replace engineers, but now we realize that we need more engineers because now the level of productivity that we can have as engineers and the impact on the business is much higher than before, right?
Yes. And the companies who will focus on smart engineer, they will be the leader in the market, right? The companies who are thinking we will be replacing human with AI, I don't think so. They will be surviving in next couple of decades because everyone is moving fast, right? So moving fast is not a problem, but the problem is like, do you have right people, right engineers, smart people who can use their judgment and make the best decision and get most out of the AI? So if you don't have smart people working in your company, you cannot do anything with AI, right?
Right, right.
Yeah.
And the way that I see it is not only does are we moving fast, but are we moving in the right direction?
It's like,
Yeah. And I agree also on the idea that having smart engineers, it becomes much more important. I think that, I'm doing labor arbitrage, right? By doing staff augmentation, building teams in Mexico for companies in the US. That's a labor arbitrage. We have AI arbitrage, which is the idea of boosting our productivity using agents, which is fine. But my thesis is that long context becomes much more important than the first two, because if you have a long tenure team that understand all the business rules and understand what happened throughout the last 3, 4, 5 years in the company, they can guide the agents and avoid a lot of the problems, provide all the business rules that are not written down anywhere, right? And supervise to make sure that they're executing correctly, right?
Exactly. So I have an example where we had an issue. Multiple engineers were trying to find out the root cause, and they were using AI. They couldn't able to figure it out, and then finally we had to call the SME, the person who has been working on that system more than 5 years, and he immediately came and he immediately, within 1 minute, he said, "Here's the problem, fix it."
Right. Yes, when you kind of know the whole history of the whole company, then that helps saving a lot of time, right?
So think about it now. Like, there is no way I can have, like, okay, I don't need that person and I can use AI. It's not going to work for me.
Right. Right. Yeah, I've seen a lot of news about those type of things where companies had to go back and rehire the people because they realize they still need them, right? And I find that fascinating, because that's where I kind of changed my perspective that the engineers are going to be much more needed in the future, right?
Until we have AGI. So let's see what happens.
Right, right. By future, I mean the next 6 months, right?
We don't know.
Right. Yeah. All of this is moving so fast that, yeah, all of this is changing. Yeah. So going back to the supply chain system, how do you manage the complexity of use cases, right? Because we're talking about all these multi-variables, right? I mean, I'm more used to, when I build automated tests, I have a use case, a scenario that I can repeat, right? But with a supply chain, you have so many variables that I can imagine that it's much harder to be able to build those test cases, right?
Yeah, I think it's all goes back to the point that we were discussing is like subject matter expertise and domain knowledge, right? So the way I organize the team is like making sure every team knows ins and outs of their system, right? They are the domain expert. They own everything related to that area end to end, right? So this is how I organize the teams. Then it's become easier. Like, okay, we know which systems we are changing. We need to go to that team. And if there is a change which is going to impact multiple systems, then we coordinate with all of those teams and involve all the subject matter experts and make sure we all are aligned. We understand how the systems is going to impact multiple systems within the supply chain and how we are going to test end to end and how this change will go on production.
Right. Right. Because you have a ripple effect, right? One change affects other systems.
Yeah. So having that knowledge and understanding is like very, very critical for me.
Is that a good ownership culture, or what are the factors would you consider part of that culture?
Yeah. So I think the good ownership culture is like making sure we define a very clear system boundaries and domain boundaries between teams.
Right.
So clear ownership between teams, clear system boundaries between systems. And we need to know exactly which system is owned by which team, right? Once we define that, then we need to make sure if there is a system X and there is a team Y owns that system, that team takes the extreme ownership. They are fully accountable for every change, every incident, every issue, even on-call rotation, everything. So they need to make sure the system is reliable, scalable, healthy, and always up. So we need to have that kind of culture and that kind of mentality. If we can build that, then it's become very easy at any level, at any enterprise level to coordinate with these team and work. So I think and one thing I would say is like culture is the architecture you do not see in the system diagram, right? So you have to make sure that's the leadership responsibility to build that culture.
Right. Right. It's invisible, but I feel it's not appreciated by upper management until there's an issue, right?
Yes, you see the issue, nobody realized, right? So
Right. right.
Having an issue is really a good sign. How fast and how the team is reacting and how fast they are resolving, that shows like how mature is the team, versus if there is an issue and the team is scrambling around and trying to find out what to do and how to resolve it.
Right.
Yeah.
Right. And the one of the things that I teach to the engineers I manage and work with is this idea of understanding how to be proactive. Because if you are too proactive and you break the boundaries set by the manager of the team, you're adding noise rather to help.
Yep.
You know.
Sometimes, yes, people have good intention, so they go outside the boundary, which is fine once in a while, but that should not become a practice. If that become a practice, that means you are going outside your ownership area, which you should not own, and you are not accountable of it. If you keep doing it, you are not doing good for the another team who is supposed to own it, and they are not going to learn it, and they will not own it end to end. Yeah.
Right.
Yeah.
Right. So I try to explain this duality of we have to be proactive, but also follow the policy of the manager, right? And then if something is going to go outside those boundaries, then just there is a time and a place and an etiquette to, bring those issues up, right?
I would still say, like, no matter what happened, like all the teams work for the same company. So everyone need to work together. Yes, we need to follow these proper system boundaries and domain boundaries. But if there is a problem which is impacting customer or revenue, then I still want all the team to come together and work together instead of saying like, this is not my problem.
Right.
Yeah.
Right. It's most of the time that I'm on an enterprise team, I do feel being a small cog in a bigger machine, right? Which is, I think it's natural, but I cannot help myself on just, speaking up when I see an issue, even though it could be outside of my area of ownership, right? Yeah. But I learned to, speaking up of an issue rather than acting on it, right?
All right. Rather than if you don't know, you don't
Right.
know that. Fine. Raise your hand,
Right.
ask for help, escalate it.
Right. Right. And then the other thing that I learned through the years is that we don't have all the context. So we don't know, everything. So it might be a great idea on my side, right, from my perspective, but there's some missing context that I might not have. That means that, I should not pursue that, improvement, whatever that might be, right? Yeah. And the idea of this being invisible is something that I kind of been putting together. I'm finishing my book about managing engineering teams, cross-border engineering teams, and nice. I call it The Invisible Distance, because it's this skill gap and cultural distance between two teams, right, that are in Latin America. That's mostly my experience, and the US, right? But I think that this applies to other countries as well, right? Or other regions where you have different cultures, different sets of expectations, right? And all of this complexity is invisible. It doesn't show up on the tickets. It doesn't show up on the wiki, right? But it's something that
we can have a different podcast for that. Yeah, it's a completely different, bigger topic.
Right. Yes. So I try to put together, rather than the technology, I try to put together the human aspect of it, because I think that's very interesting to me. And it comes from a lot of the things that I learned throughout the years, right? Some, hard lessons, or mistakes that I made throughout the years, some lessons, and yeah, I've been trying to put that together. So yeah, I'll send you the.
Yeah. Thank you so much. Looking forward to that. I think the one point you brought up is the human aspect. This is very, very important for me. Everything that we are doing at the end is for human, right? So no matter where you are working and which company you are working, always remember like being kind and being human.
Yes. And at the end of the day, I realized that it's all about building trust with the team. And for you as a manager, it goes both ways. You have to build trust with your team and also upper manager, right?
Yep. Also on the side.
Also on the side, yes. And one of the interesting things that I've seen happening with offshore teams is that, and it's kind of my thesis on the book, is as a manager, with an offshore team, you have the unique opportunity to shape how that team is going to communicate with the rest of the company. They can be an isolated island, or they can be fully integrated, or you can, precisely shape how that integration or communication is going to be, right? And I find that very interesting, right?
Yep. I think time zone makes things harder. It's a very complex
Yes.
problem to solve.
Yes. And I think the complexity around time zone is about making the wrong assumptions. The engineers make the wrong assumptions, and then they were super, super fast, but in the wrong direction. Then, now we have to go back and redo it again, right?
Yeah.
Then we lose time, right?
Yeah. But the real problem is not like time zones. The real problem is like unclear communication, right? So
Yes.
when you are working in different time zones and you have a geographically located teams all across continents, right? You have to make sure you intentionally make your communication more clear. Because we are not going to have a coffee chat or a hallway conversation or everyone sitting in the same room and having that meeting. Everyone is working on a different time zone. So the biggest practice to make the communication clear in these things is like start with async communication first, right? So write down all the decisions. I really like the logs of decisions and logs for context, right? Making sure the ownership is very, very clear between your on-site and offshore teams, right? If you are following some of these things, I think the pain that we have with time zone could be.
Yes, I agree. I mean, what I try to teach to the engineers that I work with is what I call proactive communication. Is declare on the ticket which direction are you going to go, right? That way, the manager can look at it, with the edge of the eye, and say, okay, it's kind of okay, it needs 5-degree correction, but it's fine. I can deal with that in 4 hours, and it's going to be fine, right? But if we're going the wrong direction, then the manager or the leader or whoever is coordinating the team can say, wait, stop. You made the wrong assumptions. Let's discuss it, right? Try to reduce the interruptions as much as possible.
Right.
Yeah, because
I will still say like it goes back to the extreme ownership, and in one simple sentence is like time zone exposes your unclear ownership very quickly.
right. Yes, and the cycles, the feedback cycles, are longer.
Yes.
So
Yeah, longer.
It becomes more expensive.
Yeah, it becomes more expensive. The other way to want to talk about specifically like what type of work you can give it to the offshore team. The way I think is like you need to define something for the offshore team which they can own end to end with a very minimal disruption with your on-site team. And this model works well when you are in a completely different time zone.
Yes, I've seen working very well the building during the day and then the integration testing during the night, because the next day that you show up, the offshore team build your report of what are things that you need to fix or improve in order to move forward, right? And I've seen that working pretty well. Yeah. But I think that it applies to many other use cases, right? So how do you balance staying technically deep yourself while operating at the executive level and keeping your teams moving forward?
Yeah. This was a bit challenging before AI, right? Because when you are managers of manager moving up, you slowly move away from technology. The more you go up, slowly you won't be into the weeds, right? So yes, it was challenging for me before AI, but this has become much easier with the new AI tools and the models that we are using, right? So I can brainstorm, I can like learn about any new repositories, code base pretty faster. I can use the AI tools to do my own analysis and root cause analysis and findings and etc. I don't need to like delegate it to my engineer, right? So pretty much I'm working as a first line of support for anything which comes to my team, which goes through me. And most of the time I'm able to answer them without disturbing my engineers, right? I'm pretty much every other day, I am pushing code on production. Right. I'm pushing code. This was not possible before AI, right? So AI made my life, manager's life, very easy. And I'm able to like work very closely with the engineers and understand what kind of like technical challenges that they are facing. And this is also very useful when we do the t-shirt sizing for the roadmap and planning and etc. So I do understand, go in depth and like how much time it is going to take versus like just relying on the engineer and not knowing anything about the code base or the system. So I think my role is not to replace the team's technical judgment. My role is to stay deep enough to create clarity, unblocks the teams, and challenge the assumptions which team is making. Yeah.
Right. Right. I think part of this is related to two things, right? One is having less interruptions, because when I start transitioning from individual contributor to manager, I start having more interruptions, and it was my personal productivity went down, right? But having teams, as you said, that has full ownership reduces the amount of interruptions that the team can have to you, right? Or will have to you, right? And then the other one is, I've been experiencing this myself, is that agentic coding allows you to focus more on the intention and less on the syntax of the code, right? So you can spend more time just building, right? And I can just change to a meeting, come back and say, okay, where we were, right? And you have like kind of like a pair programming buddy, if you like, right? If that makes sense, right? Have you experienced something similar?
Yeah, so I'm using the agentic coding pretty much every day. I can access the tool from my phone and just like type commands or make next steps, and the agent will keep running in the back, and I don't have to sit and watch.
Right. Yeah. And then when you come back, you have some progress that you can review, and you can come back to context very quickly, right?
Yeah, exactly.
So going back to how, you mentioned how you're using AI today. Can you describe a little more in detail how you're using AI to build software?
Yeah, that's a really good question. I think AI has changed software development dramatically, right? As I was saying earlier, the execution speed has increased drastically, right? And now more than 90% of code is written by AI, right? So I'm not spending a lot of time, and my teams are not spending a lot of time in writing code. They do spend a lot of time in like designing the solution, creating the tech specs, and brainstorming with other engineers. Somebody wanted some help from the tech lead or staff engineer. They go and talk to the staff engineer, like, "Hey, let's design the right solution, perfect solutions, right?" And then the engineer brainstorm with the AI tools and challenge the assumptions which AI is making and the output which they are getting from the AI, right? So it's being validated by human and then approved by the human. Once it is approved, AI wrote pretty much more than 90% of code, right? I also have the very tight review guidelines. So one thing I did is like a couple of days ago, I think 2 weeks ago, I used the AI tool and asked the AI tool to scan all the repositories which is owned by a team and scan all the review comments from last 3 years and then create a playbook. So it
Nice.
created a playbook, and then I gave that playbook to my team. My team reviewed the whole playbook and they made some changes. This is what we want and this is what we don't want. And now we have a very set of guidelines, which we already gave it to our agentic coding tool. So when the agents are writing code, it's referring to those review guidelines. And once the code is done, the PR is ready. It goes back and review again. So we are able to reduce a lot of like human frictions, like frictions between reviewer and the engineer who is writing code. And they are just reviewing the edge cases or extreme use cases. We are not spending any time in the usual code reviews, which can be already addressed by AI, right? And the tools which I use, it automatically watch the CI/CD and it automatically watch the review comments and it automatically address it. So the engineer doesn't need to go and keep on watching, right? So at the end, you just get the PR, which is ready for human review and ready for merge.
Interesting, right? Because you have less friction, because the agent understands how you work.
Yeah. And we can also make more improvement. Again, I'm at the enterprise level, so there's so many complexities in order to make the testing and end-to-end testing and integration testing automated, because that required a lot of work. But for the smaller use cases, I have it fully automated end to end, right? I just tell the agent, this is what I need. The agent will create a Jira ticket. It will create a PR. It will review the PR, and it can also merge the PR automatically and deploy to production.
Right.
Yeah.
Right. Yeah. I think that's amazing. I interview Swati Swoboda. She's working at Shopify, and she described something similar as you're describing. What she said is that she spent more time reviewing the code written by agents than writing code, right?
Yeah. So in the industry now, reviewing code is becoming a bottleneck for most of the companies, right?
Right.
Yes.
Right. Yes. Yes. And it comes back down to what I was mentioning before of accountability, right?
Yes.
We do need the humans to still remain accountable, right?
Yeah. But I still do think like there's so many things in the code reviews which can be automated. But I think the team has to spend time on it. And the example which I gave you is like scanning everyone's comments from last 3 years. Similar to that. So these kind of ideas, we need to start thinking about it and see how we can reduce the time where we are still doing some manual work. So I'm not saying we will completely 100% reduce the manual work. Yes, there will be still some manual work, but there are still a lot of opportunities we can reduce the overhead of the manual work.
Right. Right. Yeah. And the other challenge that I've seen happening on enterprise is that the agents are trained with open source code or generic code that does not necessarily, those patterns don't necessarily apply to enterprise. It has their own specific style. So I think that what you describe as reading the history and being able to summarize how we work becomes much more important for enterprise, because
Yes.
a new startup can just start fresh and follow the agent's leadership on designing the code.
It's also possible for the enterprises, like because every company is different, every enterprise is
Right.
different, everyone's context is different, history is different, right? They just need to dedicate it some time, whatever AI tools you are using, make sure it's fully configured. Make sure you create a deep wiki. Make sure you add as much as context you want, right? Including the architectural design, the Miro diagram, or whatever diagram you have, all the context and history as much as you can add. Then those tools will utilize those deep wiki and the context, the output will be much more better, right? So this is for the context, one part. The next thing is like, I want to talk about the creating the PRDs, product requirement document, and also the technical spec, not only for human, make sure you create those documents for AI. Right. So starting from is one, like we have a requirement, business requirement, your product managers write a PRD. So that PRD should be AI ready. And then when it comes to engineer creates the technical design, use their human judgment, their expertise, domain expertise, subject matter expertise, and then they create a tech spec, which has to be AI ready. Once you have these two things ready, writing code and quality code becomes much easier for any AI tool, whatever you are using, right? And then the processes that we talked about is like thinking about like how you can automate your testing, how you can automate your end-to-end testing. If you need to create custom agents specifically for your enterprise use cases, go ahead and create it.
Right. What I've seen working in that sense is to build the PRDs, the human reviews the PRDs, and you ask the agent to audit the PRD, and kind of go over that a few times before you start actually building the code, because then by that time you have a clear understanding of what needs to be built, right? Yeah, and getting in more detail, what I've seen working is shutting down the agent and starting fresh, because there is diminishing returns of larger and larger context, right?
Yeah, if your session becomes too long, then sometimes the agents get confused.
Yeah, so being able to just shut it down and say, okay, this is the PRD now, let's build this stage, and and then doing reviews again, because it does make mistakes, but the agent is able to kind of detect their own mistakes, right?
Also challenge it. So one thing I have been doing is like, if I get an output from AI, I always challenge it. Like I ask the AI to review it. Like, can you review it end to end? If there is a technical document, then I ask like, you are an expert principal engineer in this. Can you review this? And then it comes with the more suggestions. Oh, I missed it, and you are right about this, and I need to do this.
Right.
Yeah.
The other one that I've seen working is to say, build the code to impress a junior level engineer, right? Or once you build it, you can say, does this code would impress a junior engineer? And then it would say, oh, we need to improve here and here and here, right? And then, okay, let's do that, right? And once you get the junior, then you can build to mid and, and so forth. But it's this idea of doing these internal audits, right?
Yeah. I always ask about for any changes, have you thought about latency? Is it like going to increase the latency, reduce the latency? Is it going to impact any other feature which any other engineer is building? So things like that. The more questions you ask, the more better outcome you will get, right? And now it goes back to what we were discussing earlier. Who will ask those questions? The smart engineer.
Yes, I completely agree. Yeah. One of the things that I've been frustrated about agentic coding is, coming from experience, I want to tweak it in a particular way. I want to build it in a particular way, right? Based on my experience, I know it's the best approach. But what I notice is that when I tweak it, it complies, but then that's when the whole thing starts falling apart, because it tweak it, but then it breaks with the whole thing, right? And then I spend too much iterations, working on those small tweaks. So you can build 80% and then spend 20% of the time to build the 80%, and then you spend the rest building the last mile, right?
Yeah. Or the other way to think is like, is writing code in your style is really important, or you care about the output and the impact?
Right.
Yeah.
Right. I have mixed feelings about this, but because as an engineer, I love the craftsmanship of building really great software, code, right? But with the speed that you can build code with agentic coding, it becomes less relevant, because once you have the PRDs, the coding language becomes less important. You can build it in one language or another, and you can migrate it and switch it, and it's super fast to do that, right? So it becomes, disposable, right? So does it make sense to spend time on the craftsmanship? I don't know, right? Because
you can also
the
define
outcome becomes
your guardrails and rules and policies, whatever you want to call. Like, hey, these are the guardrails, these are the policies, before you start writing code or any project, and then I will follow those guidelines.
Yes. But when it's a language that I'm not, as familiar with, I'm kind of okay with that. But then when it's a language that I'm familiar with, I know that the quality of the code is not as good or as clear as I would build it, right? But then it's a difference between spending 6 weeks me building it or 2 days, right? So the output becomes much more important. Yeah.
Yeah. Yeah. Output become much more impact. Yes, like low latency, scalability, and some of these like best engineering practices. As long as we are checking these boxes, I think at my level, I'm less concerned about like a specific style of coding now because I have been far from coding from like many years.
Right.
Yeah.
Right. I mean, I love Ruby on Rails. That's kind of my main language. But I built a Swift command line application because it was much faster than Rails, right? Than Ruby. And I was able to compile it. And then I did the same thing with Rust. I built a Rust application because it was faster. So once I had the PR, it was easy to migrate from one language to the other, right? And is that idea that the outcome becomes much more important. And then I do audits to review what I call the surface attack, right? It's if I see it as a black box, can I penetrate somehow? Can I hack it somehow, or is it safe enough, right? So, and these are mostly tools that I use for myself, so there's not really much risk, right? But I still have the enterprise practice to do that, right? To make sure that it's, solid, right? So, but then the quality of the language becomes less important. What is important is, okay, instead of taking 15 minutes, now it takes 2 seconds. I appreciate that much more than the quality of the code, right? Right.
Yeah, you have to sacrifice something with the speed because the advantage is you are gaining a lot because of the speed and you can do so many other things, right? So if something you are sacrificing in terms of the quality, but it is not impacting your production, it is not impacting your customer impact or revenue, or the architecture is still high quality, I think we can probably bite that bullet a little bit.
Yes, I agree. The getting the outcome, validating the security becomes much more important because once you validate the security, then the name of the variables becomes less relevant because the agent can understand intent rather than names, right? So, yeah. But as a craftsman, but as a craftsmanship, it kind of breaks a little bit my heart,
Yeah, I think the next generation will have a different thinking because we came from the era where we were writing every single character by hand, right? So we care about craftsmanship. Yes.
Right. I feel like I remember this the movie Back to the Future when a young Elijah Wood was playing with a video game and it says, "Oh, you have to use your hands." Oh, this is such a bummer, right?
Yeah.
I feel like that. It's the next generation of engineers. They're going to have a whole new set of challenges compared to us, right? Yeah.
Yeah, I think the talking about the challenges, we have been into the weeds, right? So the engineers who wrote code by their hands from many years, they understand the deep technical problems, right? The problem with the vibe coding is like all of that critical thinking and judgment is slowly going away. And the way people will learn all the skills that they are missing now because of vibe coding through failures. When I say failures in software, in any system or software, when the things will break, they need to figure it out what happened, right? So when the things will break, they will automatically gain those skills that they are missing because of vibe coding.
That's very interesting because I've been thinking, when I delegate something to build to an agent by coding, then I am not learning by doing.
Yes.
Right. So how can a junior get that experience? What you're describing is they get that experience when the vibe coding fails and they
Yep.
have to dig down.
They have to dig down,
how
they
to
have to
fix it.
figure out what happened and they need to fix it, right?
Right.
How much AI will be able to fix it, we'll see. Like, I'm not sure the AI can fix everything 100%, right? We still
Right.
need people to figure it out.
And it's a new set of problems, but the core skills to solve it are the same. It's
It's the same.
curiosity.
Yeah.
Yeah, it's learning how things work.
Back to basics of software engineering, right?
Right. Right.
Yeah.
Yeah. I do feel like something like that happened to us when we come from, a disconnected childhood, no internet, no cell phones, no nothing like that. And we then grew up towards, having cell phones, having internet. We grew up towards having more connectivity, right? My son now has 10 years old, 11 years old, and he grew up with internet from day one, right? So it's a whole different generation with a whole different subset of problems, right? So I think that the same thing is going to happen with the next generation of engineers, right? Yeah, I'm both terrified and excited to see what's going to happen, right? So you patented an agent-based system for supply chain incident detection and root cause analysis, right? Can you tell me a little bit about what is that patent about?
Yeah. So before we talk about patents, I want to quickly talk about AI agents and how I'm using those. The concept of AI agents, what they are doing in my patent, right? So AI agents are very powerful when you have a complex speed or a lot of data signals coming from multiple systems, right? So if we talk about supply chain, if there is an issue in the supply chain, there might be so many signals and so many touch points which we need to verify, right? So detecting an incident sometimes becomes very critical and time consuming for human in a large enterprise system, right? So that's all the patent about. Identify all of those signals, right? So in e-commerce supply chain systems, you have orders, warehouses, carriers, suppliers, inventory, fulfillment system, customer promise, external agents, like so many things. How you can get signals from all of those different systems and quickly find out the defect pattern or find out an issue, right? And then human just focus on the high value decisions instead of figuring out and looking into all of those systems. So that's all about the patent. And this helps you in drilling down the root cause much faster and keeping human still in the loop and making sure human makes the end decision. But AI, with the patent which I had, the AI agents helping you and making the incident detection and root cause analysis much faster.
Wow, that's amazing. I think that's very interesting. Yeah, because you're delegating the decisions to a human, but you're also automating the parts that are time consuming.
Yeah. So in one sentence, I would say agents should reduce the noise for human, not remove the human accountability. So all the noise should be handled by agents.
Amazing. Nirmal, we're running out of time. I truly appreciate you being here today. Any final remark, any final advice to engineer leaders that are
Sure.
trying to work on AI?
Yeah, I really care about human aspect of it. So AI is not about replacing human, right? It's about making human faster, better, informed, and less buried in the noise. That's what I would say to the leaders.
Amazing. Nirmal, thank you very much for joining us today.
Yeah, thank you so much for having me. Nice talking to you. Thank you. Bye.